These are notes from Melham's Math 70 from Monday, May the 4th, section 12.5, page 734. This is the last section of chapter 12, and in fact the last section of the entire course. We're doing something called conditional probability. Here's a conditional probability formula. It says the probability of B given A, that slash says the probability of B given A. That means you already know that A has occurred. So that's equal to the probability of A and B divided by the probability of A. This is a formal formula. You can just plug everything in and get it, but there'll be an instance over here where it might be easier to think of it intuitively. So I mean, this will always work. You can always do it, but if you do it by thinking about what it means, it may come out to be a little bit easier, and I'll try to demonstrate that. Okay, for 3 and 5 is just plug and chug and see what happens if you can get it. All right, so again, this means the probability of B given A, that slash, you know that A has occurred. So, sometimes you can use that to eliminate everything else in the problem. All right, so here's problem 3. The probability of A given B is the probability of A and B. Sorry, I made a mistake here. I just snuck it up higher, but you guys know me. I make lots of mistakes. A and B divided by the probability of B. Notice I just kind of reversed this, but it's the same concept. The key thing is this second thing here goes over here. So you just plug in 0.25 divided by 0.4. They give you that information. That comes out to be 0.625. Then they ask for the probability of B given A. That looks exactly like this. So it's the probability of A and B divided by the probability of A. Here they just reversed it. So the key thing is that second item goes down below. So it's 0.25 divided by 0.7. It's about 0.357 and so on. And 5 is pretty much the same thing. Probability of A given B is the probability of A and B divided by the probability of B. So the probability of A and B was given to be 0.07. Probability of B is 0.18. Punch it in a calculator, 0.38 repeating. You might recall the bar means it's repeating, so it's 0.38888888 and so on. The reverse, probability of B given A by formula, is the probability of A and B divided by the probability of A. In fact, that looks exactly like this. So it's 0.07 divided by 0.61. That comes out to be about 0.1148. Now, problem 7, they give you this table. So I've duplicated the table here. 13 requires a table. I've duplicated the table here. This looks very much like a table we've seen before. So across this way, it looks like you have ages, 0 to 17, 18 to 25, and so on, all the way to greater than or equal to 50. And down you got full-time, part-time, and unemployed. So for 7, they ask for the probability of being part-time given that the age is 35 to 49. All right, so first I'm going to show it to you exactly by formula. You don't want to think about anything else. Just go straight by the formula. It'll work, but it's a lot more work than if you think about what it means, and I'll show you that option also for number 7. So to make things easier on me, I'm going to say let B represent the probability of someone being part-time, and let A represent somebody that's between 35 and 49. That way I can just go straight to the formula. We're asking for the probability of being part-time given 35 to 49. So now I've changed it to the probability of B given A. So I can make it look exactly like the formula. So again, B represents part-time, A represents 35 to 49. So it looks just like the formula. So it's the probability of A and B divided by the probability of A. All right, so once again I have to do some counting. So you add all 15 entries here, 3 times 5, it's 3179, and you might recall that's the same as the previous section. Okay, and now I want the total of the part-time, so I add down all of these is 775, and 35 to 49, it's going these 3 numbers across, add across, that's 864. Okay, so now I figure everything out. The probability of A and B means they're part-time and 35 to 49. That's just that one single box. So that's 179 out of the total of 3179. Again, that's one box. And then divide by the probability of A. So A was 864 over 3179. So that's all the 35 to 49s that's going across here. So it's 179 over 3179 over 864 divided by 3179. There's a nice math trick when you have something like this. You can just cancel the 3179s. If you're not convinced of that, multiply top and bottom by 3179. 3179 over 3179. All the 3179s cancel out. So you have 179 over 864, which is 0.2072. Okay, so that's method 1, which is going straight by the formula here. But method 2 requires you to understand what's going on. But if you understand what's going on, it's much easier. Okay, method 2. Okay, we're told that you're given the person is 35 to 49. Okay, so that means my new universe is just the fourth row. You can ignore the rest of the table. So you know the person's between 35 and 49. So forget all of this stuff at the top. All I'm looking at now, my new universe is just these three boxes, 581, 179, 104. Forget that, forget that. My new universe is just people that are 35 to 49. Okay, and we already know that that added up to what we had over here, which was 864. Now, if I only look at these three boxes, what's the probability that the person is part-time? Well, I just look at this box out of the three. So it's 179 out of the grand total of 864. Right? So the new universe is just the fourth row. Looking only at the fourth row, the probability of being part-time and 35 to 49 is 179 over 864. So if you understand what's going on in the language, it's a much easier problem to figure this out than to go straight by what it says over here. I'm going to do that same kind of trick for problem 13 because doing 13 by the formula is much more cumbersome. So this is the chart. Some things you may notice, in order for it to fit, I had to chop this off. This says Sony PlayStation, but we don't really need it that much. So I guess these are different video game consoles, Nintendo, Xbox One, Sega Genesis, and Sony PlayStation. At least I got the numbers here, they all fit. And these are age groups, 0 to 12, 13 to 18, 19 to 24, greater than or equal to 25. Okay, so they're asking for the probability that someone uses the Sega Genesis given that they're between 13 and 24. Now 13 and 24 are these two here, so I'm going to pretend that these are all 1. And now, rather than going back to this, I'm just going to do it by the new technique. So we're knowing that the person is between 13 and 24, so I'm ignoring that top 0 to 12. It's not under consideration. I'm ignoring the bottom greater than or equal to 25. So my new universe are these 8 boxes right here, 13 to 24. And out of those 8 boxes, I want the number of Sega Genesis. So it's just these 2. So all I do first is add up these 8 boxes because my new universe is just these 8 boxes. How come? They said 13 to 24. So I can ignore this, 0 to 12, it's not there. Greater than or equal to 25, it's not there. Just add up these 8 boxes, and that came out to be 1166. And now I only want the Sega Genesis people, so that's these two. So 92 plus 83 is 175. So the probability is 175 over 1166. And as you can see, this is much easier than trying to figure all of this out in this particular case. Finally, problem 15. I have to do this by formula. There's no really shortcut way of doing it. Okay, so they're asking for the probability that the sum is 8, given that the sum is even. Right? And again, to make it look like this here, I'm going to call a sum of 8 B, that event is B, and A, I'm going to say the sum is even. So probability of getting a sum of 8 given that the sum is even now looks like the probability of B given A. I wanted to make it look exactly like the formula. So it's the probability of A and B divided by the probability of A. All right, so the probability of A, what's the probability of getting an even? We've seen that before, that's 1/2. The probability of getting an odd sum is also 1/2. So if you roll 2 dice, the probability of getting an even, that means 2, 4, 6, 8, 10, and 12. We've shown that before, that's exactly 1/2. Probability of A and B, that means the probability of getting an 8 and an even number. Well, that's the same thing as saying the probability that the sum is 8, because if the sum is 8, it's already even, right? So you're not getting any new information. So I just want the probability that the sum is 8. That comes out to be 5 out of 36. So again, we know that if I toss 2 dice, there are 36 outcomes, 6 for the first die, 6 for the second die. And how do I get a sum of 8? Well, 2, 6, 3, 5, 4, 4, 5, 3, or 6, 2. So that's 5 out of 36. So I plug directly into the formula. Probability of B given A is the probability of A and B, that's 5 out of 36, divided by the probability of getting A, getting us even, is 1/2. So 5 over 36 divided by 1 over 2 means times 2 over 1. Cancel here, 5 over 18. All right, so these are notes from Melham's Math 70, Monday, May the 4th, section 12.5. This is the last section of chapter 12, and it's even the last section of the entire course. Now, Wednesday was just going to be a question and answer day, quote unquote. Obviously, we're not meeting face to face. So, how about Wednesday? Prepare for the test on Friday. You can go ahead and email me any questions if you have any. If you don't have any questions, then just be ready for the test on Friday. So, same ground rules as before. Open book, open notes, but no discussion. Due at 11:59 p.m. So 11:59 p.m. Show me all your work. Show all the work, and you can also email me your homework for chapters 11 and chapter 12.